Hi, today we're going to talk about questions on logarithms for Pure 2 International A-Level Edexcel. So let's go ahead. First of all, we need to memorize the summary points for the logarithm. As we know, the logarithm is the inverse form for the exponential form. So for example, if you have x to the power of a equals y, this is called exponential form. So the exponential form, to be logarithmic form, it will be log, and we write the base in here, and the result will be in here, and the power will be out. So what's the purpose for using the logarithms is we find the value of a missing index or a missing exponent or power. So the main point or the main purpose of the logarithms is finding the missing power. So this is called exponential form. X to the power of a equals y. This is base, this is power, and here we have the result. So if I want to change the exponential form into logarithmic form, it will be log y to the base x equals a. So how can you say it? You will read it as log y to the base x. So the base will be dropped down here, and the result will be here, and the power will be the answer. We need to know some of the summary points which are very important, like here. Log n to the base a equals x is equivalent to the form a to the power of x equals n, and a must not be 1. So you must be aware that the base must not be 1. It must be greater than 1 and not negative as well. So it must be any number greater than 1. Even it can be decimal. The laws of logarithms, log x to the base a plus log y to the base a. So we have similar bases for the logarithms and addition. Like here we have similar bases and addition. So what happens? We take one log with one base and then we multiply. What do we have here? This is called multiplication law. So we'll take one log and then we're going to multiply what's here by what's here. Then here we have log x to the base a minus log y to the base a. Whenever we have similar bases or two logarithms with similar bases, what we'll do is we will gonna keep one logarithm and then we will divide the first by the second, since here is subtraction, but you must take care that the bases must be similar. We have the power law. Whenever we have any variable or a point in here that has raised up to a power and there is log with a base a, this power will be dropped out or to be taken out. So for example, if you have log x squared to the base a, the power 2 will be shifted out there. These are the first three laws. Then we must be aware of some of these special cases. Like for example, if you have the variable is in the denominator and you want to keep it in numerator, so what you will do is, as you know, this will go up with a negative power. So the power will be shifted out like what we have done here. It will be taken out, written. So this log 1 over x to the base a will be negative log x to base a. Whenever we have the base and the variable in here, they are the same, or if we have two constants, they are the same here, like x, a, 2 to whatever number or whatever constant or variable, the answer will be 1. And again, you must be aware that the base must not be a, so here this one must not be, so it must not be 1, both of them. It must be greater, and it can be any other variable like x and x, y, and so on. Whenever we have any logarithm and the answer here is 1 to the base a, the answer is 0. Whenever again we have any logarithm and the result is a, like log a to the base a, log 1 to the base a, the answer will be 0. If you change this to the exponential form, a to the power of 0, so the answer is 1. So you must be aware of these. How to change the base of any logarithm? For example, if I have log x to the base a, if I want to split this logarithm into two logarithms with different bases, it will be log x with a new base, which is b, log a with a new base, which is b. So for example, if you have log, and here you have 3 to the base 2, and you want to split this with new bases. So for example, it will be log here 3 with the base 2 over log 3 with the base 2, or you can choose a different base. The last one is if you want to switch the base and the variable which is here, or the base and the result together. So what will happen is you will make 1 over and this, then you can switch the base and the result together. So if it's log a to the base, log b to the base a, it can be 1 over log a to the base b. So the result and the base has been changed together if you put 1 over. These summary points are very important so you can solve all the question in a simple way. Let's move on to the questions from the past papers. Are you feeling confused? Do you have problems in math? Our online courses will help you at any time. The first question, we have the questions here from the past papers. Find the exact solution of the question 8 to the power of 2x plus 1 equals 6, giving your answer in the form a plus b log 3 to the base 2, where a and b are constants to be found. Then, using the laws of logarithms, solve the following equation. So let's do the first one. For part I, how do we do it? You have 8 to the power of 2x equals 2x plus 1 equals 6. You have two different bases in here. So first of all, we can change the 2 to be the 8 to be 2 to the power of 3 all to the power of 2x plus 1 equals 6. So why did I choose to change the 8 to make it a 2 to the power of 3? Because here we are required to find log 3 to the base 2. So the base is 2. So what now we'll work on the exponential form, then we will change it to the logarithmic form. So here what will be here? It will be 2 to the power of 6x plus 3. As you know, when we have a power inside, power outside the brackets, so we multiply them. This equals to 6 in here. This can be splitted as 2 by 3 as well. So this 2 would go by division. So now you have 2 to the power of 6x here plus 3. When this goes by division as 2 power negative 1, it will be 6x plus 2 equals to 3. Now you can take log for the two bases in here, for these two. If I have base and base, they are different, you will take log to the two sides. I will take log with base 2. Why especially base 2? Because as it's mentioned in the question. So it will be 2 to the power of 6x plus 2 equals log here, log 3 to the base 2. As what you saw in the previous slides, when we have a power on the variable or the constant, this must be shifted out. So it will be 6x plus 2 out. Then we have log 2 to the base 2 equals log 3 base 2. This part, as you know, when we have the base and the result are the same, so this together will be 1. So what will be remaining here? It will be 6x plus 2 equals log 3 base 2. So now what we can do is this will be 6x and here it will be log 3 base 2 minus 2 out and here. Then we can divide both of them by 6. So it will be log. This 6 will be down here, or it can be 1 over 6 log 3 base 2 minus 2 over 6, which would be 1/3. So it can be written as negative 1/3 plus 1 over 6 log 3 base 2. So you can leave it in the form that's required in the question. Here we have a number negative 1 over 3 plus 1 over 6 log 3 to the base 2. This is regarding the first part of the question in I. If you want to do double I, we can take a part in here on the board. The question says, using the laws of logarithms, solve this one. What we will try to do is, we'll try to keep all the logarithms on one side, which is preferred to be on the left-hand side, and we'll keep the constant on another side. So I will take this here, I will do kind of swapping. This will go there and this will go here. Why? Because this one, it has 2 at the beginning, and here this one will go. So now we'll have a double I. We will rearrange the question. It will be 2 log y plus 1 to the base 5 minus log 7 minus 2y to the base 2, and here we have 1. Now what you will do is, we're gonna do kind of flashback. So this 2 will be returned as a power again. So 1 here equals log y plus 1 all squared to the base 5 minus log, so this is 5, not 2, log 7 minus 2y all here to the power 5. Now, since we have similar bases and subtraction, if you remember the logarithms, the laws of logarithms, so we will keep it as division. We'll keep one logarithm only. It will be division. 7 minus 2y, all of this equals 1. So what you will do is, since you reach it to this point, you cannot do any other thing with the logarithms. You need to change this into exponential form. As you remember, the base is here and the power is here. So this is the base of the exponential, this is the power, and this has to be the result. So now we have converted this into a normal equation. You can split. So this is 5 already, and here we have y squared plus 1, and this plus 2y all over 7 minus 2y. If you do cross multiplication, it will be 35 minus 10y equals y squared plus 2y plus 1. So if we keep them all on one side, it will be y squared, then plus 2y, and you will take inside minus to go there plus, so we have 12y, and this one will go there, 35 will go minus, so it will be minus 34 equal to 0. We have mode, then 5, then 3, a is 1, b is 12, and we have the last one is negative 34. So y is 2.36 and negative 14. Negative 14 will not be accepted, so it will be y equals 2.34 approximately. So now we're done with this one. Y equals 2.34 after factorization for solving. You can make sure by substituting here the value, then if this side is equal to this side, so it means you have successful. Let's move to one more question. We have a question here, says given that log b to the base a equals k. Find in simplest form in terms of k the following. So we need to find this equal something k. So let's see I is log, we have log root a over b to the base a. So first of all, it will be log a to the power of half. As we know, the square root is power half all over b, here base a. Now we have a division, as you know. So let's split the division. Mainly it was what before? The division, it was subtraction with similar bases. So it's log a to the power of half base a minus log b here base a, and we'll take the half out because you know the power goes out. You will be having log a to the base a minus log b to the base a. So now we need to check how can we simplify this as much as we can. This together, log a base a will be 1, so remaining here only half. And here log b base a is, which is k, so it will be half minus k. In point double I, we have log a squared b to the base a over log b to the power 3 over the base a. So what we'll do is we're gonna work on the numerator first. So we'll do the numerator. It will be log a squared to the base a plus log b to the base a, because we have the two variables that multiply by each other, so we split them all over log b. This 3 will be out base a. So in the numerator we can simplify more. This 2 will be out, so it will be 2 log a to the base a plus log b to the base a is k, as you know, so it will be plus k all over 3 log b to the base a is 3k. So now what will happen is this one will be converted into 1, so it will be 2 by 1 is 2 plus k all over 3k. So this is the answer for this part. The following, find the exact value of x for which log x plus 5 to the base 3 minus 4 equals log 2x minus 1 to the base 3. So let's see I. How do we solve I? And I, if we have log x plus 5 to the base 3 minus 4 equals log 2x minus 1 to the base 3. So we will do likewise what we have done before. We will keep the logs in one side and the numbers on the other side. So I will take log 3x plus 5 minus log 2x minus 1 base 3 equals 4. So I took this to the right hand side and this has been moved or shifted to the left hand side. Now, since you have similar bases and subtraction, it will be log x plus 5 all over 2x minus 1 all over base 3 equals to 4. So what you will do next is you will change to exponential form. It will be 3 to the power of 4 equals x plus 5 all over 2x minus 1. So you can do cross multiplication. 81 by 2. So the 3 to the power of 4 is equal to 81. So it will be 81 multiplied by 2x minus 1 equals to x plus 5. So here it will be 162x minus 81 equals x plus 5. If we take this to the other side, it would be 161x. Here 161x, and this would be minus 86 is equal to 0. We can just take the 81 to the other side, so it's 161x equals 86. So x is 86 out of 161. It will be approximately, let's just calculate this, 86 divided by 161. It's approximately 0.53423 significant figures. So this is the answer of I. Double I is two parts, part A and part B. So let's start doing double I A first, and then we'll do B. Double I, it says if we have 3 to the power of y plus 3 multiplied by 2 to the power of 1 minus 2y is equal to 108. So it will be 3 to the power of y plus 3 multiplied by 1 to the power of 1 minus 2 multiplied by 2 to the power of 1 minus 2y equals to 108. 108 must be splitted or factorized to be written in the form 2 to the power of something multiplied by 3 to the power of something. So we can use the prime factorization. 108 is divisible by 2 is 54. Divisible by 2 is 27. Divided by 3 is 9. 9 divided by 3 is 3. 3 divided by 3 is 1. So the 108 can be splitted as 2 squared multiplied by 3 cubic. And here we have y to the power of, we have 3 to the power of y plus 3. We have 3 to the power of y plus 3 multiplied by 2 to the power of 1 minus 2y. So here what we can do is we can keep y's on one side and x's on one side, or we can keep them all together in one side. So this one, it was, since the powers are added together, so mainly it was 3 to the power of something multiplied by 3 to the power of something. So it's 3 to the power of y multiplied by 3 to the power of 3. We have done like flashback, so we have returned from this to the main one, and here we are having 2 to the power of 1 over 2 to the power of 2y, because the powers are subtracted, so there was a division in here. So you will try to cross out what's similar. 3 to the power of 3 and 3 to the power of 3 will be crossed out, so you have now 3 to the power of y. Now you can cross out one of the 2's here. So it's now 3 to the power of y is equal to 3 to the power of y over 2 to the power of 2y is equal to 2 in here. So in this one, since these are multiplied together, it can be splitted as 3 to the power of y over 2 to the power of 2 all to the power of y equals 2. So now 2 to the power of 2 is 4. So it will be 3 to the power of y over 4 to the power of y, because 2 squared is 4, all equals to 2. So you can keep it as one fraction. So 3 over 4 is 0.75. To the power of y is equals to 2. This is what we need to show now, and already we have shown this. So we proved that 0.75 to the power of y is equal to 2. So once again, what we have done is we splitted the bases because the powers are added, so it becomes 3 to the power of 5 multiplied by 3 to the power of 3 because the powers are added. And here we divided 2 to the power of 1 over 2 to the power of 2y because powers are subtracted. And here 2 squared by 3 cubic because we factorized 108 by using prime factors. And then we started crossing out what's similar, 3 to the power of 3 with 3 to the power of 3, just remove them. Then we have 3 to the power of y over 2 to the power of 2y equals 2. Here, and this one, since the powers are multiplied, so it means there was a power inside and power outside, so we splitted the two powers, it becomes 2 squared all to the power of y. 2 squared is 4, so it's 3 power y over 4 to the power of y all equals 2. So we can make this as 1 power for the whole fraction, and then we converted the fraction into decimal. So it's now 0.75 to the power of y equals 2. Then point B says, double I, point B says, hence find the values or the value of y, giving your answer to 3 decimal places. Since I don't know what's the power, I will change this exponential form into logarithmic form. This is point B. So I'm going to I'll change this, it will be log 0.75, and here 2 is equal to y. So we can just do this on the calculator. If we do it on the calculator, it will be, we have the bottom of log, which is here, it will be 0.75, and here we have 2, log 2 to the base 0.75 equals, so y is 0.75. The y will be approximately equals negative 2.409 to 3 decimal places. This is the answer for y. Plus 2 equals 3, giving your answer as x equals log a to the base 7, where a is a rational number in its simplest form. So we need to keep a as a rational number, and then we need to solve this. Let's see in part I how we will do it. 7 to the power of x plus 2 equals 3. So what we'll do here, we can split this. It will be 7x multiplied by 7 squared equals 3. So it's 7 to the power of x multiplied by 49 equals 3. So we can make 7 to the power of x equals 3 out of 49. This is a rational number. Now we're going to take log, or convert this one into exponential logarithmic form. So it will be log 3 over 49 to the base 7. All of this equals to x. So now we got x as in what's the required form. So it's now 3 out of 49. And 3 out of 49 is exponential, is a rational number as was. In double I, we need to solve this one. So we have base 2, base 2, and base 2 as well. So we'll keep them all on one side, and we will shift the number to the other side. So it can be written as 1 equals log 2, log 5 minus y to the base 2, then minus log y to the base 2, then minus log y plus 4 to the base 2. And now what we'll do is, since these are all similar bases, so here we have 5 minus y then minus 5 minus y minus log y to the base. So this would be log 5 minus y all over y to the base 2, and here equals to 1. Then minus log y plus 4 to the base 2. Yeah. So this can be kept as log 5 minus y all over y divided by y plus 4 all to the base 2. So why did we do one more division? Because this and this together will be division, and then this one is one more, so we will divide. As we know this here dividing the fraction, so this one it will be 5 minus y all over, this will go down, so it will be y multiplied by 1 plus 4, and here log and base 2, all of this equals 1. So just convert this one into exponential form. It will be 2 to the power of 1 equals 5 minus y over, you can expand here, it will be y squared plus 4y, and then if you do cross multiplication it will be 2y squared plus 8y equals to 5 minus y. We can just do it up there, so it will be 2y squared plus 8y, then plus 1 more y minus 5 is equal to 0. So it will be 2y squared plus 9y minus 5 is equal to 0. So it will be 10. Just we can do, we will do mode, then 5, then 3. A is 2, B is negative 9, and C is, I think we need to change, B is 9, not negative 9, and C is negative 5, negative 5. So the first one is half and the second one is negative 1. We cannot take the negative 5. So the answer would be here half, and here negative 5 is rejected. We're having 2y squared plus 8y plus y minus 5 is equal to 0. And then it becomes 2y squared plus 9y minus 5 is equal to 0. After factorization, we'll get y. The first y is half, the second y is negative 5. So negative wouldn't work here, so we crossed out the